let's get into another challenge. This one's called Holiday 6 Shark Pontoon. Your friend invites you out to a cool floating pontoon around 1 kilometer off the beach. Among other things, the pontoon has a huge slide that drops you out right into the ocean, a small way from a set of stairs used to climb out. As you plunge out of the slide into the water, you see a shark hovering in the darkness under the pontoon. Crap. You need to work out if the shark will get to you before you can get to the pontoon. To make it easier, as you do the mental calculations in the water, you either freeze when you realize you are dead, or swim when you realize you can make it. You are given 5 variables. The shark distance, that's the distance from the shark to the pontoon. The shark will eat you if it reaches you before you escape to the pontoon. Shark speed is how fast it can swim or move in meters per second. The pontoon distance is how far you need to swim to safety in meters. Then you have your own speed called U speed. In the method they call it your speed. How fast you can swim in meters per second. And then there's this extra dolphin Boolean value where if it's true you can half the swimming speed of the shark as the dolphin will attack it. Doesn't sound very plausible to me, but we'll run with that. The pontoon, you, and the shark are all aligned in one dimension to keep things simple. And then simply if you make it, return alive. If not, return the text shark bait. So, clear enough. We'll head over to the coding window. Now's your chance to pause and try this yourself. Come on back when you're ready. First things first, before we get into the solution, I would make a comment. This method is hideous, right? 5 parameters here. It's so much information that they felt like they had to put a new line for each parameter. And that's something we call, or at least I would call, a code smell. It's sort of this term that we use when there's something off about a design. Maybe you're not entirely sure what it is, but it doesn't feel right in an unpleasant way. And so for me, I would package all of these parameters up. I'd make a struct to hold these, and then I would simply pass the struct as a parameter, as a single parameter. You know, maybe you could wrap this all in a struct called, you can name it after this shark pontoon or scenario details, something like that. And then pass one parameter to the method of that struct type. When you make methods, the fewer parameters that you can have, the better. It's simpler, it's easier to think about. So try and use as few parameters as possible. Reduce your designs to the simplest implementation that you can. Do yourself a favor. Anyway, that said, they define this signature. I'm not going to mess with it. We'll leave it as is. Okay, now into coding. So first thing, I'm going to handle this variable situation where you may have a dolphin or you may not. So for that, let's make a float called actual shark speed. And I suppose you could do this as a double too if you prefer. And we have 2 scenarios where a dolphin is present or it is not. If the dolphin is present, we're going to use this ternary operator that we talked about in a previous challenge. If the dolphin is present, it's said to use half of the shark speed. So to make sure we're doing floating point arithmetic here, because I don't want to lose any precision. If you divide with integers, it'll truncate values. So for example, if you say 10 divided by 3, you're not going to get 3 1/3, you would just get the 3, so you kind of lose some data there. So I'll cast it to a float. I'll say shark speed divided by 2, and as long as one of these, the numerator or the denominator or the entire operation, are casted to a float, we've seen casting before too, then the arithmetic will be carried out that way. And then simply use the shark's speed, right, if no dolphin is present. So that simplifies our shark speed. And then after that, I wanted to look at this problem as there's a time that it takes for the shark to reach the boat, and there's a time that it takes for me to reach the boat. And if the shark can get there quicker than I can, then I'm dead, right? So I'm going to calculate those two values. We know that they're both along a single axis, so there's no kind of weird angles or anything. And that's why I can make the calculation as simple as that. So first, I'll grab my, let's call it your time to boat. And how can I calculate this? I can take the distance I'm at, right? That would be for me pontoon distance. And I can divide that by my speed, right? Because my speed, consider the units on these. Pontoon distance would be in meters. My speed is in meters per second. If I'm dividing, that's like multiplying against a reciprocal of that, which would be seconds per meter. And the meter values cancel out, and I'm left with seconds. And so that tells me, that puts the number of seconds that it takes me to reach the boat. Again, I don't want any truncation to happen, so I'm going to use float here, casted, so I get a decimal value as needed. And that should cover my speed. You could certainly put in dummy values if you wanted to make sure you understand this and it makes sense. Imagine you're 10 meters from the boat and you can swim at a rate of 2 meters per second. Not realistic, but just bear with me. Then your time to the boat is 5 seconds, right? And you can, hopefully that you believe me that that equation works. And then you've got one of these shark time to boat, right? Probably going to do the same thing here. And then we have a shark distance that they gave to us. And then we're going to use our actual shark speed, right? Could be different whether a dolphin's included or not. So we want the actual shark speed here. And then finally, now that I know the times that it takes both of us to get there, I can simply, instead of return, we'll use a ternary operator again. Shark time to boat is less than your time to boat. You're in trouble, right? If that's the case, oops, question mark, shark bait, they said to do, else alive. And really it comes down to that. Let's give this a run, see how that goes. Yeah, good. Running low on battery here, so I'm going to rush this along. Make sure we're good. That test passed, great. And yeah, hopefully that was pretty clear. Let's submit. I don't really have anything to clean up. Yeah, and feel free to scroll through the other answers. We're submitted, we got our points there. Good stuff. As usual, hit me up with questions, comments. Otherwise, we'll move on. Thanks.